For thousands of years, humans have looked up at the sky in wonder. The sun, the moon, and the stars have shaped our stories, our calendars, and our sense of time itself. But among all the cosmic events we witness, none are as dramatic or as mysterious as an eclipse. Today we will journey far beyond Earth, past the clouds, past the atmosphere, into the grand stage where the sun, the earth, and the moon perform a breathtaking cosmic dance. A dance so precise, so delicate, that even a slight change in timing or position would make eclipse impossible. What exactly is an eclipse? Why does it happen? And why don't we see one every day? Join me as we unfold the story behind one of the universe's most astonishing alignments. The moment when daylight darkens, shadows stretch, and the heavens show us the power of geometry in motion. To understand eclipses, we must start with motion. The Earth orbits the Sun once every year. The Moon orbits Earth once every 27.3 days. These motions create a constantly shifting triangle of positions between the three bodies. But there's more to the story. The Moon's orbit isn't a perfect circle. It's tilted, angled by about 5 degrees compared to Earth's path around the Sun. That tiny tilt explains why eclipses are rare. Most of the time, when the Moon passes between Earth and the Sun, or when Earth passes between the Sun and the Moon, the three bodies simply don't line up perfectly. Only when their orbits intersect at two special points, called nodes, can we experience an eclipse. Nodes are like cosmic crossroads where the paths of Earth and the Moon momentarily overlap. Once every few months, the Sun, the Earth, and the Moon sink into near-perfect alignment at one of these nodes. And when that happens, magic begins. A solar eclipse happens when the Moon moves directly between Earth and the Sun. For a few extraordinary minutes, the Moon blocks sunlight, casting a shadow onto Earth. But not all solar eclipses are the same. There are three main types: partial, annular, and total. In a partial solar eclipse, the Moon covers only a portion of the Sun. Daylight dims, but the Sun remains visible as a crescent. In an annular eclipse, something special happens. The Moon is slightly farther from Earth, appearing smaller in the sky. Even when it aligns perfectly, it cannot fully cover the Sun. A brilliant ring of fire surrounds the Moon. But the most dramatic of all is the total solar eclipse. For a brief moment, the Moon covers the Sun entirely. Day turns to twilight, temperatures drop, birds go silent, and stars appear. Imagine standing in the Moon's shadow, looking up as the Sun's corona, the outer atmosphere, blazes into view. A sight so rare and breathtaking that people travel across the world to witness it. This is the beauty of perfect cosmic alignment. A lunar eclipse happens when Earth passes directly between the Sun and the Moon. This time, it is Earth's shadow that takes the stage. Unlike solar eclipses, lunar eclipses can be seen by anyone on the night side of Earth, making them far more common to witness. There are also three types of lunar eclipses: penumbral, partial, and total. In a penumbral eclipse, the Moon glides through Earth's faint outer shadow. The darkening is subtle, often barely noticeable. In a partial eclipse, a chunk of the Moon appears bitten away as it moves into the deeper umbra. And then, there is the total lunar eclipse. When fully inside Earth's shadow, the Moon does not disappear. Instead, it turns a haunting shade of red. Why red? Sunlight passing through Earth's atmosphere bends around our planet, scattering blue light and allowing red wavelengths to slip through, gently lighting the Moon. The same effect that creates sunsets now paints the moon in fiery crimson. This is the legendary blood moon. At this point, you might be wondering, the moon orbits Earth every month, so why don't we see a solar and lunar eclipse every 30 days? The answer lies in the tilt we discovered earlier. Most of the time, the moon is either slightly above or slightly below the line between the sun and Earth. Only when the moon is near one of its orbital nodes, those special crossing points, can a perfect alignment occur. Think of the orbits as two hula hoops tilted against each other. They touch at only 2 points. Unless the sun, the moon, and Earth meet at one of those exact points, the shadows simply miss. Eclipses happen only during eclipse seasons, which occur roughly every 6 months. During these periods, the geometry is finally right, and the universe sets the stage for shadow and light to perform their ancient ritual. At the heart of every eclipse is a simple but powerful idea: shadows. The sun casts 2 kinds of shadows: the darker, central umbra, and the lighter, outer penumbra. During solar eclipses, the moon's small umbra reaches Earth's surface, creating a narrow path of darkness called the path of totality. During lunar eclipses, Earth's much larger shadow engulfs the moon. These shadows shift, stretch, and slide across space as the celestial bodies move. The angles, distances, and sizes determine whether we see a partial eclipse, an annular eclipse, or a total one. Shadows in space are the universe's invisible storytellers, revealing the shape, size, and motion of worlds without a single word. Throughout history, eclipses were seen as omens, messages from the gods, dragons devouring the sun, celestial serpents swallowing the moon. Today, science allows us to understand their beauty without fear, but the sense of wonder remains. Eclipses remind us that we are part of a vast universe governed by elegant laws. They show us how tiny motions, just a few degrees of tilt, a few minutes of perfect timing, can create events unforgettable to the human eye. Whether it is the sky turning to night during the day, or the moon glowing red under Earth's shadow, eclipses are a powerful reminder. Our world is connected to forces far beyond us. The next time you witness an eclipse, look up, not with fear, but with curiosity. You are watching the universe at work.